So we did L2 on Thursday, and we had some, kept calling them log laws. But what they were our limit theorems. And we did it so nice on Thursday. Everything worked out. You could do direct substitution to check. Or put your phone away. Oh, okay, sorry. I'm sorry. You just were so distracted on the paper. So today we're getting into why we would use those limit theorems. So when you do direct substitution and you evaluate, and you get that indeterminate, what do we do next? So we're gonna have to do some algebra. We're gonna have to do some limit theorems, not log laws, and we will hopefully come out with the correct answer. All right, so if you see IF or indeterminate form, that's what I'm talking about. So indeterminate form is when we have 0 over 0. Like when we actually substitute in and it gets us that answer. So if we were to substitute in, we're going to take the limit of 3, and that we're direct substituting in for x. If we do that, we get an indeterminate. Hey, you rearranging the furniture? Okay, perfect. True story. This is my desk and I had to buy an extra table because I have too much stuff. So in order to make this happen, we got to do a little bit of math first. So what I'm going to do is I'm going to keep my limit. So limit as x approaches 3, and I'm going to factor my numerator. And that is a difference of squares. I hope everybody saw that. I know, this is what happens when we have 4 students. You'll be okay.
I think they should combine stats and calculus class together because they even have like 4.
Oh, really? Is it tiny?
What's the biggest same as calculus class? You know, like 4 students.
Calculus stats has had some bigger ones, and I think the draw to stats is that it's a full credit, but yeah, maybe we look at making them half credits and just combine them. Yeah. Calculus plus stats. Stats is the course that we made at Artie Parker because we had so many students going to university into nursing programs or other programs where they had to take one math course and they ended up in stats and they had just never seen it before. So again, it's kind of like just a soft introduction into what it's going to be like in uni. So here, if we go ahead and we do direct substitution in here, so we drop the limit when we do direct substitution. So we know that this limit is equal to 6. You could do this with a table of values, but that would be super tedious. And you would pick values less than 3 and greater than 3. So if I were to do a table of values, I know that 3 is 0 over 0 if I do direct substitution. So we would pick values like 2.99, 2.9, maybe 2.5 here, and we'd see what number they're getting close to, and then we'd pick like 3.001, 3.01, 3.1, and as we get closer to 3 from the other side, what values are we getting close to? So if you're not sure mathematically what to do, a table of values would definitely help. I'm not going to actually do the calculations because I know it works out to 6, but you could totally do that way just to help if you're not sure, right? It's always good to have a backup plan, a second plan. All right. So here is another one that if we do direct substitution, so x is approaching 4. If we put 4 in here, we're going to get 0 over 0. It's not going to work. When we can use direct substitution, absolutely use it because it makes more sense for hat. But this time, we can't do that. So anytime you have a square root and you get an indeterminate, I would go ahead and use the conjugate. So the conjugate is the difference of squares partner. Always do it with the one with the root sign. So I want the conjugate to that one. So difference of squares just means that we change the sign in between them, right? Like this would be the conjugate. But as with any math, we don't want to change the value of it. We can't just times the numerator by it. We have to times both the numerator, sorry, that should be a minus. We have to multiply both the numerator and the denominator by the conjugate. Because we know that that has, you know what I think I'm going to do? I think I'm just going to put a multiply sign in between them. Because we know this one has a value of 1. Like you can't just do it to the numerator because that's bad math. That's going to change the value. That has nothing to do with being in a limit or anything. We just never do that. Okay, so now we're going to multiply. Okay, I'm not going to multiply the denominator. And you guys are going to question my sanity for that, but I promise you, if we multiplied it in, I'm going to end up having to factor it out anyway. These are going to cancel each other out. I don't know what's up with me and the plus signs today. So now we see why I didn't multiply the denominators. So these will end up canceling each other out. So we have the limit as x approaches 4. And if I do direct substitution, I drop the limit. So it equals 1/4.
But Miss Caroline, why do you come all the way down to do this?
What?
Like, why couldn't you just do direct substitution?
See, if you weren't on Reels, you'd know that. What happens if we do direct substitution?
Oh, we end up with the
We get that indeterminate form, that 0/0. So we have to do some math to it. So if you do direct substitution and you get 0/0, that just means you got to do some algebra before you can actually go back and do your direct substitution. You can't leave a question as an indeterminate. Like you can, but you won't get any marks for that. So anytime you're seeing something with radicals and you end up in indeterminate form, use the conjugate and use the conjugate for the thing with the root sign. All right. Pardon? 4 minus 6? Oh, the example here. So these are the conjugates. It's just to show you that you keep the two variables and the I is just a variable, not an imaginary number. So if it's 4 minus 6i, then it's going to be 4 plus 6i is the conjugate. No, sorry. It was a crappy example. I stole it from the internet. I apologize. This is what happens when you borrow things from the internet. Do they have stuff on calculus on Instagram? Yeah? Great stuff, good stuff. Okay. Here we go. So,
Can you do it alone?
Pardon?
How are denominators gonna help us?
Common denominators are going to help us a lot with this one. So when I'm looking at the numerator there, what's the common denominator for that? 2x, right? So I'm going to multiply this by 2 over 2 and that by x over x, right? So I'm going to have 2 over 2x minus x over 2x all over x minus 2. Oh, holy Hannah. Didn't use enough big brackets there. Okay, so let's simplify this a little more. Now there is another way to do it. I just find it, this is the way we always kind of look at it, so it makes a little bit more sense. So my numerator will be 2 minus x over 2x divided by x minus 2. Okay, so what do you guys notice here? I think at this point, just like in an identity, I'd get away from the fraction inside of a fraction just because I think that hurts my head. And I can't always see it super clearly. So I'm going to have 2 minus x over 2x divided by x minus 2. So do you see something close but is a problem? And do we know how to fix it? Right, we know how to fix it. This and this are almost the exact same thing, but they're not right now. So if we common factor out that -1 out of here, and I'm showing you all the steps. There are definitely ones that you can, are you guys okay if I just write it as x minus 2? Because this would be a -2 and a positive x. I just like, and I'm going to change this to a multiply. And I'm going to multiply by the reciprocal. So I'm doing a couple of math steps, nothing too crazy. So now I can go ahead and cancel stuff out. I think sometimes the hardest thing about this lesson is just knowing what to use where. Like that's the hard part. So now when I do the direct substitution, I'm going to get -1/4. So it's just what algebra do I do in a situation that doesn't make a ton of sense, but it's kind of like identities. Like you're going to use the strategy that makes the most sense, multiply by a conjugate. We've done that a lot in identities. Multiplying by or getting common denominators. Again, a strategy we used in identities. So all those like little tips and tricks are going to be what we do here to deal with the indeterminate.
We don't know what can we do like the limit theorems.
You can totally do the limit theorems. That would work as well. Or you can always go to a table of values. That wouldn't be, it's a longer strategy, but if you have nothing else in the bag, a table of values will never lead you wrong. You okay, Rahab? Okay. So here's where things get a little bit messier. Not the end of the world, but just a little bit messier. Okay. So here we go. So we have to notice something about the notation. It's saying, hey, the function here, the function of 1 plus h, and we're going to go a little bit more into this, where h is incredibly tiny, small increments. Just like we did in that table of values, that's usually what we say h is, are these little tiny, tiny, tiny values. So if we were going to evaluate this, if we substitute in h is approaching 0, so you put a 0 in here, we have f of 1 minus f of 1. What does that give us? 0. You're taking a function and you're minusing it from itself. You're just going to get 0. H is approaching 0. We get this indeterminate here. So, not great. But that's okay. We're smart people. All right. What normally goes in this bracket here? What normally happens? What's our normal notation? Yeah. Usually it's f of x. So what we're going to do is we're actually going to expand this one. So we're going to replace the function notation with the actual function. So there's my actual function. So it's a little bit more complex because we're substituting stuff in. So we're going to say the limit as h approaches 0, so that doesn't change. We're going to take f of 1 plus h. So everywhere we see an x in this formula, we're replacing with 1 plus h. You ready for this? So we're going to have 2, 1 plus h squared minus 5 times 1 plus h plus 1. Okay. Now we're subtracting, I'm going to use a bracket here, the function when x is 1. So this would be 2 times 1 squared minus 5 times 1 plus 1. All over h. Holy Hannah. So it looks ugly. There's lots of it that looks really ugly. Are you guys okay with that thin pen that I'm using? Like, should I use a thicker pen? Is it hard to read? It's fine. Allie, how about you? You're without your glasses today. It makes me nervous.
I forgot that one. I'm good.
Okay, you're good?
Yeah, I can tell what's on there.
If not, you can always grab my notes. Okay, so now let's clean some stuff up. We got to expand this. We got to expand that. So that's going to be 2 times 1 plus 2h plus h squared minus 5 minus 5h, because that negative is distributed through everything there, right? Plus 1. And now we're dealing with this at the back here. So 2 minus 5 is negative 3. Negative 3 plus 1 is negative 2. So we have a subtract negative 2 all over h. And I'm showing you all the steps. There are so many things that you can combine and make smaller. But I think sometimes if we don't actually... I think the danger sometimes is to go quickly, and with stuff with lots of letters in it, lots of things we're substituting, lots of things we're expanding, there's a danger in kind of getting lost in it. So I'm going to have 2 plus 4h plus 2h squared minus 5 minus 5h plus 1 plus 2 all over h. Okay, I definitely have a 2h squared. Just gonna write that down. Okay, so I have a 4h and a negative 5h. So I'm gonna have negative h. And then I have 2 minus 5 is negative 3 plus 3 is 0. And so we did all that. We got this expansion. If we did direct substitution in here, we'd be right back to where we were, 0 over 0. But there's more stuff we can do. We can factor now. There's no denominator there. So the limit of this function is negative 1. So that was an awful lot of math to get to negative 1. But that we're going to do a lot more of in the other units. We're going to be doing lots with that plus h because we're going to see how it affects different things. We're going to use straight lines to find curves. It's going to be a good time. And that's it for lesson 3. So those first 3 things are gonna be on your quiz, which will be on Wednesday.